Hi everyone. Today we can discuss on different types of optic fibers. In the previous classes you had seen what is an optic fiber, its structure, working principle and numerical aperture. The optic fiber has three coaxial regions. The innermost region is called core. It is surrounded by cladding, and outermost region is called sheath. Depending on the refractive indices of core and cladding, the optic fibers are broadly classified into two. They are step index fibers and graded index fibers. Step index fibers are abbreviated as SI fibers. Graded index fibers are abbreviated as GRIN fibers. First we can see the structure of step index fiber. The innermost region, core. The refractive index of the core is high. Let it be N1. It is surrounded by cladding. Let refractive index of cladding be N2. For a fiber, refractive index of core N1 is greater than refractive index of cladding N2. This is an important relation for an fiber, for an optic fiber. This is the central axis of the fiber. As we move from the axis, refractive index is N1 up to this boundary. At this core cladding boundary, N1 suddenly decreases to other value N2. There is a step between core and cladding. So this is called step index fiber. So here for step index fiber, core has uniform refractive index N1 and cladding has refractive index N2. N1 is greater than N2. For some practical purposes, we are using very small sized core, and for other practical purposes, we are using large sized core. Depending upon this, again, we can classify step index fibers into two. So for one category, the core is very small. If the core size is very small, the light rays propagate through the fiber like this. All light rays follow straight line path. For this fiber, diameter of the core ranges from 1 to 10 micrometer. If core size is very small, the light rays follow straight line path. The path of light through the fiber is called mode of propagation. Here only one path is possible, meaning only one mode is possible. So this fiber is called single mode fiber. Single mode optic fiber. In short, it is called SMF, single mode fiber. Here all the light rays take same time of propagation. So the light rays can reach here the destination at the same time. So the output will be more clear, no distortion in this case. Then we can see the second category of step index fiber. Here the core is large, size of the core is large. In order to send more data, bulk data, we are using large sized core. Typical diameter of this is in the range 50 to 100 micrometer. Here, if we feed light into this fiber, some light rays follow straight line path. These rays are passing through the axial region of the fiber. Consider another light ray strikes obliquely like this. First, after refraction and total internal reflection, this light ray follows a path like this. We can consider one more light ray entering like this. The path of this ray again different. Let this ray be 1, 2, 3. Ray number 1, which is passing through the center of the fiber, is termed as axial ray. Rays 2 and 3 are called peripheral rays or marginal rays. These rays follow zigzag path through the fiber. The axial ray takes less time to reach the destination, while these rays, zigzag rays, take more time. So these rays cannot reach the destination at the same time. So the output is distorted or dispersion occurs. So this type of fiber cannot be used for long distance communication. As distance increases, distortion also increases. In this fiber, if the size of the core is large, light rays travel through different paths. Multiple paths are possible. So this fiber is called multi-mode fiber. Multi-mode fiber, MMF. So this is about the classification of step index fibers. In single mode fiber, size of the core is very small. In multi-mode, size of the core is large. In single mode, diameter is in this range 1 to 10 micrometer. In this, diameter in the range 50 to 100 micrometer. In single mode, only one mode of propagation is possible. In multi-mode, multiple modes are possible. Single mode fibers can be used for long distance communication, while multi-mode fibers are not suitable for long distance communication. So this is about step index fiber. Then regarding the multi-mode fiber, the distortion is very high. We can rectify the problems. We can rectify the effect of distortion by using graded index fiber. So we can see the modification of the structure of graded index fiber. This is the core of the fiber. This is the central axis. Here we can make high value of refractive index for proper doping process. From the center towards the cladding region, refractive index decreases. This is cladding, but the cladding has constant refractive index N2. The value of N1 is not constant in the case of graded index fiber. It is high at the center and gradually decreases towards the cladding region. So this is called graded index. Refractive index is graded. Refractive index is changing. So that is why this fiber is called graded index fiber. So since the refractive index is very high at the center, velocity of light decreases. So the axial ray travel with less speed. It covers shortest distance, but it travels with less speed. And here the region has less refractive index, so speed is high. So here the marginal rays or zigzag rays travel with high speed, axial rays travel with less speed. So in effect, all the light rays can reach the destination at the same time. So there is no chance of distortion in the case of graded index fiber. So about the light ray, consider a light ray entering into the graded index fiber. It is moving from denser to rarer medium continuously. So refraction occurs, and after continuous refraction, this will be the path of light through the fiber. So light follows curved path or parabolic path through the graded index fiber.